Hello, today we'll be looking at force and extension. Force and extension. We all know what force is. We said force is something that creates a kind of change to either the shape, speed, or the position of an object. But now in this case, the force is used for something else. Now we say we have a spring that was extended by 5 centimeters. We should know that whenever we're given a question like this, the first thing to do is to write down the values we're given. Now from here, we're given the value of the extension E is given to be 5 centimeters. And we're given the force acting on it to be 10 Newton. Now we want to know what the new length is when the old length before the load was put on it was around 3 centimeters, which this is called L1, or we call it LO. Let's call it L1. Let's call it L1. So in this equation, it's quite easy. I already told you the extension is equals to L2 minus L1. The L2 is what we're looking for. We're looking for the new length after the load of 10 Newton was added to it. This is very easy. So the extension here is going to be L2, we don't know, and we know the extension to be 5 Newton. So we're going to write a 5 Newton here. We're going to write a 5 Newton here. I'm going to write the 5 centimeters here, equals to L2, which we don't know, minus L1, which is 3 centimeters. From this equation, we can transfer 5 centimeters. When the minus sign go over the equal sign, it's going to change to plus 3 centimeters. It's going to give what the L2 is. Now from here, the L2 is going to give you 8 centimeters. That means when the force of 10 Newton was added to the spring, it extended by 5 centimeters. Now the new length became 8 centimeters. That's fine. Now let's say we have the next question says we have a spring which is 4 centimeters long. We have the L1 equals to 4 centimeters, and we don't know what the L2 is, and we are given what the load, the force acting on the load is for the force acting on the spring is said to be 4 Newton. Now what we want to know, we said what will be the new length. Now before we know what the new length is, we need to know what the extension is. The extension is not known now. The formula here says force is directly proportional to extension. That tells you the greater the force is, the greater the extension is. The lesser the force is, the lesser the extension will be also. Now from this equation, we can find what the constant K will be. Now F equals to K extension. Now we know what the force is, and we want to know what the extension will be, but we don't really know now because we've not got any equation to solve that. So now let's say the constant to be 1. Let's say the constant K equals to 1. So now here we're going to have the force equals to K E. Now we'll substitute for F to be 4 Newton and the K to be 1 E. Now we want to know what the E is. We divide through by 1. Excuse me. If you want to know what the E is, you divide through by 1 to know what the E is. So now from this equation, we can easily divide through by 1 to know what the value of E is. Okay. Now divide through by 1 here. So E extension is going to be 4 centimeters. The extension is going to be 4 centimeters. And now we already know what the equation says. The L extension equals to L2 minus the L1. Now the extension is said to be 4 centimeters, and we know the L2 to be, we don't know, and the L1 is 4 centimeters also. So to know what the L2 is, we need to make this 4 to come over the equal sign and see what we have there. So we're going to have 4 centimeters plus 4 centimeters equals to L2. So now the length 2, that is to say the new length, is going to be 8 centimeters after the load of 4 Newton was added to the spring. So in this equation, we can really see now that the force acted to a spring is directly proportional to the extension. And in some cases, we may be given that we know what the L2 is, the new length is. Let's say we know the new length to be, let's say we have the L2 to be around 10 centimeters, and we have the L1 to be 4, and we want to know what force is acting on that spring. So in this equation, now let's solve for the next one. We don't know what the force acting on it is. We want to find what the force is. So it's fine. We write all the values to be, excuse me, let's move to the new slide to find more ways to solve it. Okay, now let's say we have the length 1 before the load was put on it to be 4 centimeters, and the L2, the length after the load was put on it, is 10 centimeters, and we want to know what the force acting on it is. And the equation says force is directly proportional to extension, and we say force equals to constant extension, and we say let's assume the constant is 1. So this tells you force equals to E. Okay, now we want to know what the force is. We need to know what the extension is first. Extension, as I told you earlier, is equals to L2 minus L1. So now the L2, the new length after the force was added to it, is 10 centimeters, and the length before the load was added to it is 4 centimeters. And it's going to give you 6 centimeters to be the extension of the spring. Okay, now we know what the extension of the spring is. We want to know what the force is. Don't forget the equation that says the force is directly proportional to the extension. Now when we have a constant to be 1, the force equals to E. So that tells you our force here also is going to be force is going to be E, and the extension E equals to 6 centimeters. That tells you the force is going to be 6 Newton. That tells you when the force of 6 Newton was acting on the spring, the extension was also 6 centimeters. Now, from this equation, we can also infer some other things. That when you say you have, let's say we have a force of 10 Newton acting on the spring, and the L1 was 4 centimeters, the length 1, and we want to know what the length 2 is. And we want to know what the length to, or we want to know what the extension of the spring will be. So from here, we say force is directly proportional to extension. Force equals to constant extension. We have the force to be 10 Newton, and we don't know what extension is, equals to Ke. Now we need to assume the constant value is 1. So 10 Newton equals to extension. So from here, we can easily say that the extension will also be 10 centimeters if the value of the constant is 1. But sometimes the value of the constant changes. In that case, we will have to change the value of the force. The value of the force will be quite different from the value of the extension also. But the question, the main point says the force is directly proportional to the extension of the spring. I hope this is really helpful. Thanks very much for listening.